Welcome to this explainer. India's space program isn't just about launching communication satellites or sending rovers to the moon anymore. Actually, they're stepping right up to answer some of the absolute most profound questions in astrophysics. Today, we're going to dive deep into how India is studying the most extreme objects in the universe, specifically black holes and neutron stars, using this incredible mission known as XPoSat.
Because this topic is packed with some pretty intense science, we've broken it down into 6 clear sections for our journey today. We'll hit the cosmic mystery. What is X-ray polarization? India's historic mission, the engineering challenge, global partnership, and finally, the future outlook. Let's just jump right in.
Section 1. The cosmic mystery. Black holes and neutron stars.
So we are talking about literally the most extreme and violent physics happening in the universe right now. But this presents a massive, decades-old problem for scientists. How on earth do you measure a black hole's magnetic field? I mean, you can't exactly send a physical probe into a black hole or a pulsar. If you did, it would be ripped apart instantly, right? These celestial bodies are surrounded by chaotic, unimaginably powerful magnetic fields that dictate how they blast massive beams of energy into space. But from our vantage point here on Earth, those magnetic fields are essentially invisible.
Section 2. What is X-ray polarization? The missing key.
To solve this grand cosmic mystery, astrophysicists realized they needed a completely new way to look at the energy being blasted into space. Enter polarimetry. Now, polarimetry is the measurement of the exact direction in which X-ray waves are vibrating, rather than simply measuring how bright they are. It's absolutely crucial because it allows researchers to map the exact shape of massive magnetic fields that would otherwise remain totally hidden from us.
To really visualize this, think of looking at a bright, glaring body of water. With the naked eye, the glare is blinding, right? You can't see anything beneath the surface. But when you put on a pair of polarized sunglasses, they block the light vibrating in certain horizontal directions. Suddenly, the glare is cut, and you can see perfectly clearly right into the water. Well, X-ray polarimetry does exactly this, but for the chaotic radiation emitted by neutron stars and black holes. It literally cuts through the cosmic noise.
Historically, the old way of studying these objects relied entirely on measuring the intensity, meaning the brightness, and the timing of the X-rays. But physicists realized that just measuring brightness wasn't giving them the full picture of what was happening in those chaotic fields. This new way, it maps the actual direction of the wave's vibration, which unlocks much deeper, fundamental physics about the universe itself.
Section 3. India's historic mission. Entering the elite club.
Now, this brings us to India's highly strategic leap into pure astrophysics. If we trace this timeline, back in 2015, ISRO launched AstroSat, which was a multi-wavelength observatory. It studied X-rays, sure, but only using that old method of measuring intensity and timing. Fast forward to 2021, NASA launches IXPE, which was a dedicated polarimetry mission. And then on January 1st, 2024, ISRO officially launches their own dedicated mission, XPoSat. That launch date is highly significant because it makes India literally the second nation on Earth to possess this incredibly specific, highly advanced space observation capability. Think about that. Until 2021, no country had a dedicated X-ray polarimetry satellite. Now, India stands right alongside NASA at the absolute forefront of this science. It's a huge deal.
Section 4. The engineering challenge. Trapping X-rays.
But getting there, it was not easy. It required overcoming a massive physical hurdle regarding how X-rays actually behave in space. The engineers faced a daunting problem. High-energy X-rays pass right through normal mirrors. Usually, when you think of a traditional space telescope, you picture these giant, curved mirrors capturing and reflecting light, but you cannot simply catch or reflect high-energy X-rays that way. They're just too energetic. They blast straight through standard materials like they aren't even there.
So how do you measure something you can't even catch? Well, the brilliant minds at the Raman Research Institute in Bangalore spent years figuring this out. They developed a highly complex solution known as a Thomson Scattering mechanism, built right into the primary payload called Pollux. Instead of trying to reflect the X-rays, this mechanism forces the X-ray photons to scatter off electrons. This clever little trick allows the instruments to precisely trap and measure their polarization angle. Honestly, it's an absolute masterclass in scientific engineering.
Section 5. Global partnership. Completing the cosmic puzzle.
Rather than a fierce, competitive space race, this specific scientific achievement is actually a beautiful global collaboration. NASA's IXPE satellite and ISRO's XPoSat are perfectly complementary. NASA's satellite was built to look at soft, low-energy X-rays, while ISRO's XPoSat is uniquely designed to measure hard, medium-energy X-rays. So by sharing their data, NASA and ISRO aren't competing at all. They're teaming up to create a complete, uninterrupted picture of the cosmic X-ray spectrum. It's like putting together two halves of a giant puzzle.
Section 6. Future Outlook and Takeaways. Beyond Launch Providers. So what does the future actually hold for XPoSat and India's evolving role in space? Well, the mission operates on a very clear plan. Step 1, of course, was successfully launching into low Earth orbit. For Step 2, over its planned 5-year lifespan, XPoSat will continually operate its two main payloads, POLIX for polarization and XSPECT for spectroscopy. And Step 3 is where the real magic happens. They're going to use those tools to observe about 50 of the brightest known active galactic nuclei, magnetars, and pulsars in the cosmos. The massive takeaway here is really about scientific prestige. XPoSat firmly proves that ISRO has matured. They are no longer just a launch service provider putting communication satellites into the sky for other people. They have become a global powerhouse in pure, fundamental space science, actively doing the complex physics research needed to test Einstein's theories of relativity. They are literally pushing the boundaries of human knowledge.
Okay, to wrap up this explainer, I want you to lock in these 4 core memory triggers. First, the mission itself, XPoSat. Second, the core science behind it, Polarimetry. Third, the brilliant minds who built the payload, the Raman Research Institute. And finally, the overarching goal of all of this, advancing fundamental astrophysics.
And that leaves us with a truly thrilling thought to chew on. We already know ISRO is preparing to put humans into space with the upcoming Gaganyaan mission. But watching them master the invisible magnetic fields of black holes with XPoSat really forces us to ask, what other extreme, fundamental laws of the universe will this elite space program rewrite next? Thank you so much for joining me for this explainer. Keep your curiosity alive, and I'll see you next time as we continue to unpack the universe's most fascinating topics.